Welcome back to the deep dive. Today we are stripping away the sleek UI, the marketing gloss, and the one-click checkout buttons to look at the engine room of modern
Yeah,
commerce.
the absolute core of it all.
We're talking about the database, and honestly, looking at the stack of research we have here, engine room feels like, well, an understatement. It's more like the central nervous system.
It really is.
Okay,
And
yeah.
it's a nervous system that is under a tremendous amount of pressure right now. The scale of what we're dealing with in retail, especially post-pandemic, has completely changed the architectural conversation.
Exactly. I was reading through this comparative study, the one pitting the old guard against the challengers, and they led with the 5 V's of big data:
Yes, the 5 V's.
volume, variety, velocity, veracity, and value. It sounds a bit like a corporate retreat slide deck, but when you actually
Mhm.
apply those words to a global retailer, the implications are kind of terrifying.
It's not just buzzwords, it's a survival checklist. You have volume, which
Mm.
is, self-explanatory. We're generating petabytes of data.
Mhm.
Then velocity, the speed at which that data arrives,
Mhm.
streaming in from millions of phones at once. But variety is the tricky one. It's not just need rows and columns anymore. It's images, reviews, click streams, social media sentiment.
And veracity is the data actually accurate? Because if you have massive volume and high velocity, but the data is wrong, you're just making mistakes faster than anyone else.
Right.
And that brings us to the central conflict we're exploring today, the battle of the databases. With all this data, where do you put it? Do you stick with the rigid, reliable rows of SQL, or do you jump ship to the NoSQL challenger?
It's the classic architectural showdown. On one side, we have the relational model, represented in our source material by Oracle Apex. That's the SQL approach.
The one we've known since the 70s.
Exactly. And on the other side, the NoSQL squad. Graph databases like ArengoDB, wide column stores like AstroDB, key value stores like Redis, and document stores like CouchDB.
And the mission of this study was pretty direct. Stop looking at the feature lists and actually run them into the ground. They simulated a retail environment processing orders, managing customer relationships, to see which model handles the pressure best. And I'll be honest, the results were not what I expected.
I think that's a common assumption, right?
Yeah.
There's so much hype around NoSQL being the modern solution.
Totally. I went in thinking the shiny new tech would just wipe the floor with the legacy stuff.
Well, before we get to the winner, we really have to unpack the rules of engagement. Because these databases aren't just different brands. They are built on fundamentally different philosophies. We have to talk about acid versus base.
Right, the theological divide of computer science. Let's break this down because this distinction dictates everything. So, acytotomic, consistent, isolated, durable. This is the relational database mantra.
Correct. And the most critical letter there is A for atomic. It means a transaction is an all-or-nothing event.
The classic example is the bank transfer. If I send you money, it has to leave my account and enter yours. In an ACID system, if the power fails halfway through, after it leaves mine but before it hits yours, the database just rolls the whole thing back.
Like it never happened. It prioritizes consistency over everything else. It locks the data while it's working to ensure that no one else can touch it until the transaction is complete.
Which sounds great. I definitely want my bank to be ACID compliant. I don't want eventual money.
Exactly.
But then we have the no-SQL philosophy, which is base. Basic availability, soft state, eventual consistency.
And here the priority flips. The A in base stands for availability. The system says, I don't care if things are perfectly synchronized right this second. The most important thing is that the system stays up and accepts the request.
This is the philosophy of the internet giants, right? If I post a photo, you might see it instantly, but a friend in Tokyo might not see it for 5 seconds because the data hasn't replicated to the agent servers yet.
That's eventual consistency in a nutshell. And for a social feed, that soft state is fine. No one's life is on the line if a cat photo is 3 seconds late.
But this is where the retail context gets spicy. Because retailers aren't just posting photos, they're selling inventory. If I buy the last pair of sneakers and the system is eventually consistent,
Someone else might be able to buy that same pair 2 seconds later because their server didn't know you bought them yet. That is the oversell nightmare.
wow. Okay, so that's the core tension.
It is, and that's why this showdown is so interesting. Heavily distributed systems often lean toward base because locking down data across 50 different countries is just too slow. It's computationally expensive.
So keeping that tension in mind, speed versus safety, let's look at the actual race results. They ran a bulk load test, shoving 1,000 records into these systems. Who's the Usain Bolt of this group?
No surprise here for anyone who works in the back end. It's Redis. the key value store. It handled those bulk operations in just 0.725 seconds.
That's absurdly fast. It's barely a hiccup. But we should explain why it's so fast. It's not magic, it's architecture. Redis is primarily an in-memory database, right?
That's the biggest factor. It lives in the RAM, not on a hard disk. Access is instant. But the second factor is its simplicity. It's a key value store. It's effectively a giant hash map.
Hash map is a great term for it. It's just a label in a bucket. You say, give me the data for key 123, and it hands it over. It doesn't check relationships. It doesn't enforce rules.
It's a dumb pipe, but a very, very fast one. And that's why it's the industry standard for things like shopping carts or user session management. You just want it to remember user X has item Y and recall it instantly.
But the downside is pretty stark. You can't ask Redis complex questions. I can't say, show me all the users who have a red shirt in their cart and live in Chicago.
Redis has no idea what a shirt or Chicago is. It just sees blobs of data. To do that, you'd have to pull all the data out and write your own code to sort through it, which completely defeats the purpose.
So pure speed, but zero analytical depth. Now, what about the heavy lifter in the study, AstraDB? It's a wide column store based on Cassandra.
Right. It clocked in at 4.65 seconds for the load test. So significantly slower than Redis, but still very respectable. The superpower of wide column stores isn't single query speed, it's throughput at a massive scale.
This is about horizontal scaling. If your Black Friday traffic suddenly spikes, you don't buy a bigger computer. You just add more cheap servers to the cluster.
Precisely. It is designed to drink from the fire hose. It's perfect for writing massive logs, every click, every scroll, every interaction.
But, and there is always a but with these NoSQL options, the study highlights a major pain point with AstraDB querying.
The query-first design requirement.
You have to know exactly what you want to ask before you save the data.
That's it. In a SQL database, you can just dump data into tables and figure out how to join them later. In a wide column store, if you want to look up a customer by email, you have to store the data keyed by email. If you later decide you want to look them up by phone number, well, you might actually have to duplicate the data into a new table keyed by phone number.
That sounds like a maintenance nightmare, data duplication.
It's the price you pay for that scale.
Yeah.
And the study emphasizes that wide column stores generally don't support joins. So if you want to see a list of orders with the customer name attached,
The database won't do that for you. You have to write that in your application code. You fetch the order, then you fetch the customer, and you glue them together yourself.
which adds complexity and potential latency. You're trading database convenience for raw architectural scalability.
Speaking of complexity, let's talk about the connector. Retail is all about relationships. This person bought this, which is similar to that. This feels like home turf for graph databases.
It absolutely is. The study looked at ArangoDB, but you can also think of Neo4j. Graph databases model the world as nodes, the things, and edges, the relationships. It's a very intuitive way to map out a recommendation engine.
I love that visual, the detective's wall with strings connecting everything. But in the study, ArangoDB didn't exactly crush the general retail benchmarks.
It struggled. The researchers noted very high CPU usage, and it required significant tuning to get it to perform well on standard tasks.
But wait, why would that be? If it's designed for connections, why does it eat so much CPU?
Because traversing a graph is computationally heavy. If you are doing a deep network query like finding friends of friends of friends, graph is mathematically superior, a SQL database would choke on that. But for a simple select from orders, a graph database is just overkill.
It's like driving a Formula One car to pick up groceries.
Perfect analogy. It's high maintenance and not designed for that kind of stop-and-go traffic. It's a specialist tool.
Okay, one contender left before the verdict, the flexible one. CouchDB, the document store. This is the darling of startups because it's schemaless.
Right. It stores data as JSON documents. The appeal is obvious. If you want to add a middle name field to your customer profile, you just start sending it. You don't have to ask a database administrator to alter the table structure.
That agility is addictive. You can move fast. But the study found a pretty significant penalty for that flexibility when it came to querying.
The MapReduce problem. To query data in CouchDB, you often rely on these MapReduce functions, which can be verbose and complex to write compared to a simple SQL query. But the bigger issue in the study was the update mechanism.
Yeah, I caught that. If you want to update a single field, say, just changing a zip code, you aren't just updating that field.
In many cases, you are rewriting the entire document. The system has to load the whole JSON, modify it, and save the whole blob back. For high-velocity updates, that is incredibly inefficient compared to SQL, where you could just update a single cell.
So we've met the lineup: the speed daemon Redis, the scalable AstroDB, the specialized graph, and the flexible document store. But the study simulated a standard retail environment, order management, and CRM. And the winner for overall balance was the old guard.
Oracle Apex. The relational SQL database took the crown.
I feel like there are a lot of developers listening who are groaning right now. After all the hype, all the conferences about web scale, the technology from the 1970s won.
It did, and it won because of consistency. And I don't just mean data consistency, I mean performance consistency. Oracle wasn't the fastest at everything. Redis smoked it on raw reads, but it didn't fail at anything. It had low CPU usage, predictable behavior, and crucially, it handled the complexity of joining tables natively and efficiently.
It's the deflate strategy. You don't have to be the fastest sprinter if you can also throw the javelin and run the marathon without passing out.
Precisely. And this brings us back to why SQL still wins for order management. It goes back to that ACD concept. It's about constraints.
This is a huge point. In a SQL database, the safety net is built into the floor.
Right. You can define rules at the database level. You can say it is physically impossible to insert an order if the product ID doesn't exist in the product table, or inventory count cannot be less than 0. The database enforces the law.
Whereas with most NoSQL options, the database is just a passive bucket.
Exactly. It accepts whatever you throw at it. So the responsibility for data integrity shifts entirely to the developer. You have to write code in your app. Check inventory. If inventory is greater than 0, then subtract 1. Then save.
And if the developer makes a typo, or if there is a race condition where 2 requests hit that code at the exact same millisecond.
You oversell the inventory. You corrupt the data. You're moving the safety responsibility from a battle-tested engine to your own fallible application code. In retail, that is a massive risk.
So the verdict isn't that NoSQL is bad, it's that we might have overcorrected.
That's the key insight. The study pushes us toward what we call polyglot persistence. It's a fancy term for a hybrid architecture.
Use the right tool for the job. Don't be a maximalist.
Right. Use Redis for your shopping carts and caching because you need that blazing speed.
Yeah.
Use AstroDB to log your massive click streams because you need the right throughput. Use Neo4j to detect fraud rings.
But for the core ledger, the source of truth about who bought what.
For that, the relational model is still undefeated. It provides the structure and the ACD guarantees that the core business logic demands.
It's funny how the boring technology ends up being the backbone while the exciting stuff lives at the edge.
That is a recurring pattern in tech history. We invent new things to solve scale, but we realize we still need the old things to ensure integrity.
Before we wrap up, there was one final nugget in the research that I found really compelling. It wasn't about code or speed, it was about heat.
Yes, the hidden cost of the database showdown, energy efficiency.
We are always asking, how fast is the query? We rarely ask, how many watts did that query burn?
And the papers point out a huge gap in our current research here. We know data centers are consuming a terrifying percentage of global electricity. If a graph database requires 90% CPU load to run a query that a SQL database can run with 10%.
Then the graph database is arguably much more expensive, even if the response time is the same. It's costing you in electricity, cooling, and hardware wear and tear.
Exactly. Efficiency isn't just about milliseconds anymore. It's about the physical cost of computing. I think we're going to see energy per transaction become a major KPI for CTOs.
It changes the definition of performance. It's not just speed, it's miles per gallon.
I think that's inevitable.
So for the architect or the developer listening, or even the business leader trying to understand why their engineering team is fighting, the challenge is clear. Don't just grab the tool that's trending on Hacker News.
Look at your data. Is it structured? Does it need strict integrity? Then don't be afraid to use SQL. It's not outdated, it's specialized for correctness. Sometimes the most innovative choice is the one that gives you the most stability.
Because at the end of the day, your customers don't care if you're using a fancy graph database or a dusty old SQL server. They just care that they got the sneaker they paid for.
And that you didn't lose their credit card number.
Precisely. That's it for this deep dive. It's a complex landscape, but hopefully it's a little clearer now. Check your stack, question your assumptions, and we'll catch you on the next one.